In this video, I am going to do implicit differentiation using this equation. What I am going to do, I am going to take the derivative of both sides of this equation and try to solve for y prime or dy over dx. Just on a side note, the typical differentiation involved in the explicit form, that is, you are given y is equal to f of x is equal to some function in terms of x, like sine of x minus ln of x or something like that. However, here it's not given in that format. So in order to find the derivative of y with respect to x, we are going to do something called implicit differentiation. That means we take the derivative of both sides with respect to x and then try to isolate or solve for dy over dx. And if I do that, this is what I'm going to get, d over dx. And I'm going to kind of rewrite it slightly. 1 over x square is the same as x to the power negative 2. And 1 over y square is the same as y to the power negative 2. And take the derivative of right side with respect to x. And using the power rule, I'm going to get negative 2 times x to the power negative 2 minus 1, which is x to the power negative 3, plus negative 2 times y to the power negative 2 minus 1. Then using the chain rule, I'm going to do dy over dx, and that should be equal to 0 because 2 is a constant. Derivative of a constant is 0. So if I simplify it, I'm going to get 2 over x cube minus 2 over y cube dy over dx is equal to 0. I could factor out negative 2. That's going to give me 1 over x cube plus 1 over y cube dy over dx is equal to 0. I factor out negative 2 and divide both sides by 2. Because 2 is a constant, but non-zero constant, I can divide both sides by 2. I mean negative 2. Now, if I solve for y, which is very straightforward, I'm going to get dy over dx is equal to negative y over x whole cube. So that's what it is going to be. So derivative of y with respect to x is going to be negative y over x raised to the power 3. And that's how we do implicit differentiation. I hope that this discussion was helpful. Thank you very much.